Hello everybody. So here we are again for another calculation lesson. You did really well last week with taking away from 100. So today we're going to look at not where you've got all the numbers, because we've kind of come to the end of that really now. Did lots of when we were at school. So we're going to look at some missing number problems. Okay, some missing number problems because they often throw people, but really with the maths skills that we have, they aren't as tricky as a lot of people think. So I'm going to kind of reveal that to you today. So if we look at that first problem at the top there, we've got 32 add something equals 67. So essentially what that's saying is that we've got 32 things, objects. We need to add some more, so we then finish with 67. Okay, so the first step in method 1, I suppose, is let's draw that 32 down. So we've got 3 10s, 2 1s. Okay, now we need to make sure by the end of the question that we finish with 6 10s and 7 1s. So if I've got 3 10s at the moment, I need to then add some more, so I end up with 6 10s. Okay, so at the moment I've got 1, 2, 3. I now then need 1, 2, 3, 4, 5, 6. I've now got my 6 10s. At the moment I've got 2 1s. I need to finish with 7 1s, so I'm going to add some more on. So 1, 2, 3, 4, 5, 6, 7. There we go. So now in total, if we count up the 10s, we've got our 6 10s. And if we look at the 1s, we've now got 7 1s. So we need to look at the bit that I added on, which is the green parts. And that's going to tell me how much I added on, and that's going to fill our blank space. So I added on 3 more 10s down here. And I added on 1, 2, 3, 4, 5 1s. So there we have it. 32 add 35 equals 67. Okay, and we can prove that with our columns. 2 add 5 equals 7. 3 add 3 equals 6. 67. That's what our answer was, 67. Now, the other way you could look at this, and again I'll give you a bit of a choice, is to think about the numbers that you do have. If we take that away, in fact let's get rid of all this actually. Medium, there we go. Let's get rid of all this. So it doesn't become too much on one screen. I don't want to confuse anybody. There we go. So the other way to look at this would be to think about it as a bit of a bar model. Okay, so with the question that we've got the largest number. Okay, so when you add 2 numbers together, it gives a large number. So this 67 at the end here is our large number, so that's going to go in our large bar. 67 down here. We've got one of the parts, which is 32. So if we did 67 take away that 32, there you go, take it away, we should be left with our missing number. Now if we think back to what we've just done, that missing number was 35, we thought, by doing it the drawing way. So let's see if we do this, if we end up with 35. So I've got my whole number, which is 67. I'm going to take away the 32, which we've got as well. Let's see if we end up with 35. So 7 take away 2 equals 5. 6 take away 3 equals 3. 35. We have ended up with exactly the same number. So either of those ways is absolutely perfect. Okay, so it makes it look a little bit easier, I think, than what a lot of people think. Now, if we look at our next example, the missing number might not always be in the middle. It might be at the start, but that doesn't mean that it should be any trickier at all. Okay, because this part and this part, they are parts, so they are changeable. it doesn't really matter in addition which way round they are. They could be swapped. So it could, the same question really is 41 add something equals 96, which is more similar to what we had in the first example. Okay, so let's think about our drawing method again. We've got 41. We need to add some more, so we've got 96 at the end. Okay, so let's add some more 10s. At the moment, we've got 1, 2, 3, 4 10s. So we need 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. I've now got my 9 10s all together. All together. Oh, what's going on there? All together. Okay. Now at the moment I've only got 1 1, that one pink 1. I need to finish with 6 1s. So I've got 1, 2, 3, 4, 5, 6. There we go. So the bit that we've done in blue is the bit that we've added on. So if we count that, we know which number to put into the blank space. So we've got 1, 2, 3, 4, 5 10s we added on. And 1, 2, 3, 4, 5 1s as well. So 41 add 55 equals 96. Right, let's check that then using our inverse calculation. Putting those values into the bar and seeing how we can use the numbers that we are given. Let's make that bar full. There we go. So our large number at the end of the addition calculation is 96. That's going to go into the large bar. It's the largest number out of the ones that we are given and are going to have. And then we've got one of the parts, which is this 41. So I'm going to put it in there. So we now know if we take 96 and we take away 41, we should be left with this missing number. Now, if we think about before, that missing number we calculated to be 55. So let's see if we do this, whether we end up with 55. So we've got 96. And we're going to take away that part we are given, this 41. Now let's see if we end up with 55. 6, take away 1 is 5. Nope. There we go. 9, take away 4 is also 5. There we go. So we end up with 55, which is exactly the same answer as we had before. Okay, so I'm going to give you some questions in the task part of WeDuck with some missing numbers. Please feel free to do as much drawing and as much calculating and as many bar models, as many columns as you need to work these out. Okay, because that's how we're going to get to the correct answers, and that's what the best mathematicians do, as we've talked about in our class. Okay, that's all from me. Thank you very much.